not that one. What? Where am I streaming? Okay. Okay, so this does work. Wait, who is this guy? Oh. That's embarrassing. I thought that was my brother. Okay, so what do I need to build? Okay, I need to remember the controls. What the? Maker pen is always M, really? Oh. Oh. Okay. So, I guess if I'm gonna make a basic Word2Vec, I'm gonna need... Oh man, this has been a while. Okay, oh man. Oh. What's the button to snap to things? I think I just have to put one down properly. Whoa. Okay, so we're gonna have one hot representing sentences. I can do, I guess we'll just do a vocabulary of 10. What should the vocabulary be? What's one of the examples I have right now? So we got, holy moly, this is gonna be hard. I'm just gonna write it down on a notepad. Okay, nothing bad. That wasn't anything bad. Okay. So, and then we can do dog. So we'll do two article adjectives. Dog, cat. And then we can do runs, walks, jumps, barks, meows. That's 9. We'll do loudly, quietly, so that's 11. I'll add fluffy. Yeah, barks and meows will be the main difference there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could use 3 more. I guess we should go to 16. So, 4 more. We can do, what's a cat exclusive? Purrs, howl. Okay, so 2 left. Oh, I guess adverbs. More adverbs. Or we could do preceding ones, so we can do quickly and slowly. Okay. So that gives us a list of 16 words. And we can have, so you have noun, verbs, adjective. Oh, I don't have okay, we can do big, small. Jumps, walks, jumps, runs. Those are 3. Barks, meows. That's 2, 2. Runs and jumps. So we'll just get rid of that. And then we'll do big, small, fluffy, and what's the big, small, cute. Okay. There's our 16 words. And we have noun, verb, adjective, adverb. So, okay. So those are the words we were running with. You do noun, verb. So that leaves us with 4 parameters per word. Or so per word. So this would realistically get like a 0, 0, 1, 0, or something like that. That's if I'm trying to make it associated. I think this should work realistically. Like, let me check. Could I train, seems good enough. Well, is that how this works? Oh man. Okay, so I'll have to make a really robust corpus for this to train it on. But okay, I'm gonna move this out of the way, and we're gonna start building this. So I'll need, wait, okay. Oh, what was the limit for Rec Room? I think it's 512 values. That's for an integer list. Or I guess we wouldn't do that. We'd do a float list. So we have a list float, and this is where we would have our first matrix multiplication. No, I guess this would have all of the different words in it. So given that we have 16, oh, that actually shouldn't be too bad. So we have 16 variables. Oh my goodness, I forgot I can draw. This is huge. So it's called an art canvas. Okay. Oh my goodness, I have my pen somewhere around here. Yes, okay. So, basically, okay, sorry, I'm just moving some stuff out of the way. What am I doing? I don't have to do this in Rec Room. I can just draw this out myself. Okay, good, good, good. The pen still works. Please don't be something horrible. Okay. Okay, so we have something, so we have a total dictionary of 16 words, and realistically speaking, I'm going to have them be just split between noun, verb, adjective, adverb. So we'll have like fluffy, and that will be, so since this is an adjective, it should realistically just be like this. Anyways, so the issue with the float list is in Rec Room, it has a max limit of 512 values, which is pretty bad. But given that, well, okay, wait, let me think. So we input, so we have 16 words, and that should give us, we can make a sentence. So like, that's not a word in the dictionary. Fluffy cat meows. So that's 4. Was I planning on making sentences any longer than this? So A dog runs loudly. A cute dog runs. Okay. So that means that we will have at most a sentence of 5 values. So we put in, how does this work? Wait, this isn't word generation. This is defining the actual, like, putting definitions to words right now. So I guess we would take, okay, so never mind this. This was all wrong. So we have that dictionary of 16 values. So what we'll do is we literally just first input the one hot, which is literally just going to be a 0, 1, 0, 0, 0. Like, let's say, like word 1 is the and word 2 is a. This one hot represents the word a. And then when we multiply this, or like push this into our like defined matrix for matrix multiplication. So, okay, this is technically a bad example, but let's just say like it's like that. So these are randomized actually. These are technically randomized, but we can assume that, so there's no value to these right now. But what we can do is, because they don't understand what A should be, but by the end of it, hopefully, there should be a split resembling this. So we don't actually know what any of these things are. So this will be empty, basically. And if it's, I say empty, but it's, what just happened? So these are all like random. Every single one of these are random. But when we do the matrix multiplication, because it's row by column, so did I forget how matrix multiplication works? Row by column. Oh yeah, no, it's fine. Anyways, so this is basically just going to fetch us the value for A, which, given that we're only, it could be like 0 0.1, 0 0.7, 0 0.3, 1.2. So that's what multiplying this one hot into our like dictionary does, is it output to that specific value. So if we had like a 1 here, it would give us this row. But since the 1's here, this goes to 0, this goes to 0, 0, this goes to 1. So all of the values in here are just multiplied by 1, which just yields the items that were in here. So that's all that we're doing for the first step. So that's not going to be too hard at all. That just means so this is going to be 16 long. It's going to be 16 long, and this is going to be 16 long. So we're going to have a 16 by 4. So 1, 2, 3, 4, 16 times that way. So that's going to be our list float. And since there's no actual way to have a 2D matrix, we're just going to have to do some math, because this is just going to be like just a bunch of variables. Just going to be a bunch of variables, like nothing separating this from this. So we're just going to have to do math when we're doing the calculations, so just every index of 4 for that. And then, so that's list float 1. We don't even need string. I'm so used to using string because the original this original project, I have it running with full 28 by 28 resolution, which when we're training, so we're plugging in all, okay, so basically 28 by 28 yields larger than the 512 limit when it is run through the whole operation. Yeah, it's 784 values. So obviously that doesn't fit. So what I had to do instead was go to a list string. And then each of those strings, because I think the limit for this is like 1024 or something like that per string, it would just be a bunch of floats. So that resulted what? How does this work? Oh. So that results in garbage like, yeah, like this, where I'd have to split it into the different strings, and then for every single item, split that again, and then parse the floats, add that to list and whatnot. So, yeah, that's what I used to have to do, but since we're doing such a small toy example, I don't really need this. So we'll just be working with list float variables for once, which is really nice. Anyways, so I'm going to go back to here just so I can wrap my head around what I have to do next. So after we do all that multiplication, blah, 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 yep, it's the normal softmax. Wait, so we get the word embedding. We check that against a matrix. What is this? So, boom, that gives us the lookup layer, yeah. Get the scores and softmax. So this second matrix that we're multiplying against. Sorry, I'm not using the pen anymore. Whoa, there's no way it's that small. It literally just is too. No way. So the matrix. Whoa. Okay. So I got this idea very wrong. Basically, not basically. I didn't get it wrong per se. Okay, wait. Did I just turn my mic off? No, my mic's still on. Okay. So basically, so we have this whole program, or this whole architecture, but as you can see, like for this 16 by 4, most words can't be described in just these 4 different like subjects. So here, for context, if I have the word like this one's common, you'll see this one everywhere, bank and bank. Obviously, these two are contextually okay. I said obviously, but let's go to the riverbank. Bank robbery. So there's 2 different types of bank, and to contextually like clarify that these are 2 different objects, it takes a lot more than just labeling it as a noun, right? So that leads to the embedding spaces per word. Instead of being just 4, the embedding dimension could be, I don't know, like GPT-3, it's like 30K plus or something like that. So 30,000 different variables that will be, depends on the architecture. It can go from -1 to 1, -1 to 1, but typically it's 0 to 1 because -1 kind of explodes sometimes, and there's like division. I think. So anyways, that's what's happening with that variable. So what I'm doing right now with, can I not make this big? Oh, I can. So what I'm doing right now with our small example is it's super small, but imagine if the vocab was more than 16. So like, I don't know, like 500,000, and the embedding size was 30,000. All of that makes a huge, huge array. And what we're actually doing with our small toy example is we essentially just end up with our 4-digit with our 4-digit value, and then we just multiply that into this is the confusing part about this, because there is something, I don't know where this like dot is coming from. Oh, that's just the mouse recentering. Oh, okay, that was fine. Oh, it's fine. Okay, that's funny. Basically, am I going to describe this now? I guess there's no reason not to. Okay, so in Word2Vec, which is what I'm trying to recreate, which is super easy to recreate here, it's basically you take the input vector of Word, and you're like, so, okay, the end result of this is like this cool little, everyone likes showing it, it's like a little 3D graph, and it'll show like the vector for like man, and the vector for like king, and then the vector for, I don't know, like woman, and like queen. And when you take the difference of these two, okay, I really messed that up. Okay, I'm gonna actually show the correct version of this. Basically, yeah, there we go. When you take the difference between these two, they should be the same. Okay, that's still really bad, but that means, so if you take like queen minus woman, that vector that you're left with, or that direction, should be the same as king minus man. And you're looking at this and you're like, okay, so that means one vector per, right? So no, okay, it's actually not that crazy to understand, because think about it like this. So if I have the word cat, I have the vector cat, and where the vector points is surrounded by, we can say, similar words. So if this point for cat says, hey, I point here, and this, and then we can have like the word like dog points here, and like cheetah, and I don't know, human. So these are all saying the, okay, what would this classify? Would these classify as, what does it point to, or what points to? Okay, so the input output is weird. So if we have the input for cat, it would be surrounded by the output vectors of the words like meow, or hisses, or like purrs, or jumps, or something, because these are words that often come after the word cat, right? So, but at the same time, this doesn't show what points to the word cat. So meow, this vector for meow, doesn't point, holy moly, I'm losing it. This vector for like meow or something doesn't point to the spot where it's near words that precede it. So like meow, like you'd think like the words like loudly or something, or like meanly. Is that a word? Um, those are the kind of words that would be after here if this was an input vector, but it's the output vector, meaning it's surrounded by words that point to it. So in this case, this point here would be like jumps, and it's surrounded by this and this and this and this. These are all words that precede the word jumps. So cheetah jumps, the dog jumps, the cat jumps. So all of these point to the word jumps. And this is like pointing like there, right? This is really hard to explain. I'm gonna have to explain this better during the actual like lecture, but I guess this is fine to practice with. So anyways, this lecture, oh, why did I say lecture? Once it finishes jumping, holy moly, I'm just saying words to say words. Am I gonna get kicked from my own room? Okay. Anyways, input, output vector, blah, blah, blah. So that means there is a vector database of values representing the output, and then we have a vector of input. Actually, I'm not going to explain this in the lecture. I'm just going to pretend there's only one. But just for the sake of this, since I'm actually doing it technically, I'm going to explain the full thing. Literally all we're doing is multiplying these two. Which is really funny. Yeah, that's all we're doing. And what it does is when you multiply these two different vectors together, it's like this. I forget, it's like cosine similarity or something. Anyways, you do a calculation and you can see like, oh, they're 0.37, like that's how related they are. So if the word, okay, this is actually not bad. So if we have the word cat here, nope, that's output, meow. We have the word meow here, and we have the word cat. What we want is, if let's say we want the word, so cat meows. So let's say that's what we want. That's what we want to end up with. That means that cat should very strongly point to meow, and meow should be very strongly pointed to by cat. So what this results in is, since these are both two different values, what this results in is cat and meows are decently close, but they're not pointing to each other properly, or not like in the correct zones. So we'll actually move cat just a little bit down, and we'll move meows just a little bit up, so that we result in something like this, where the two words are now much closer together. So now this similarity between the two means that meow is more likely to come after after the word cat. That's all we're doing. So we take, hey, this is we get their similarity, like this. Maybe like 0.36, and we're like, no, if they're similar, if they're perfectly similar, it should be 1. But it's not 1. So how can we tweak the values in here? How can we tweak the values in both of these? Just a little bit. So that's why we have something called a learning rate, because otherwise they would literally just be identical or whatever. And it's not just two words. Like a cat can do more than just meow. So we just want to kind of nudge it into the area where it's like surrounded enough. So it's not too close. So it's very close to things that it's supposed to be, and it's kind of close to things like cat like coughs or something. So it's a little farther than that, and then it'll be very far from like barking. That's the goal, okay? That's all the matrix multiplication that happens. And yeah. So what, but it's anyways, so yeah, that's all we're doing. So all I need to make is input. Okay, I have a mouse, I have a pen, so all I need to make is input and output. And so I need to make the matrix mult function with dimensions of 4, and then the softmax function, and then the loss function, and then the tweaks to input and output. And I technically only have to, I can just end it here because I'll do the training on my laptop or on my computer if this takes too long. But it should be okay. Because this will... Okay, actually I have no idea the limits of Rec Room this time because we're working in such a small area. So matrix mult. Multiply. I wish so badly there's an easier way to do this. List get element. So you want to get 2 of these, and we will add those to a list float sum. So we will add this to a list sum, and we'll get 1 more float list here. They'll all be added into that. So list of this, index of, we can just do a basic for. Oh, is that new? That's the same thing. Oh, list add, that's what I was thinking of. Okay. Okay. So there. Okay, now I'm just gonna move some stuff around. Okay, so get element. We're going to multiply these 2. Wire this into here. List add this into this float here. Move this here for organization. And then for each item, we're going to have it add there for each item in... Uh-oh, wait. Well, there's not items, because it's... Yeah, no, we'll have to do a custom for because it's not different items there. Okay. Oh yeah, this is perfect. So we can do from 0 to 4. Zero to 4. So for each item from 0 to 4 in, we're going to be working with this is bad. We'll get wait. No, it's just every 4 items we just sum that. Yeah. So we literally just can do the for each element in here. Okay. List get element for each. Okay. This should be an int, right? Yeah. Oh. Well, I know how long this is, so I can just hard code that in. Or actually, we can be a little more robust there. Size. List. Oh. List get count. Yeah. So oh, don't clone these. So this can be W1. Oh wait, no, this could be input. And then this can be oh, I probably named it something already. Okay. So these two. Input will be the same dimension as this. Will it? So we take input vector. Okay. So first we take our one hot. So this is where we just choose our word. Then we take our dictionary. Okay. Run the multiplication. Okay, good. Okay. So we run this. This isn't. I forgot. I forgot cross versus dot. Oh man. I have a sore on my tongue. Wait. Okay, so this will yield us these 3 x's. And then we check it against we take this, so it's row column, so that times that, that times that, that times that. And then we add that at the end, and then so that'll give us like 0.5, this could give us like 0.2, 0.4, 0.9, blah, 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 and then we take the softmax for that, which is like e to the x, or like 1 minus e to the x, or something like that. Anyways, it's like, I have Google. I had it, basically, kind of, I think. Okay, so that means we get, okay, how am I going to translate this to Rec Room? So for each value in here, no, for each value in here, well, so this first multiplication is just one hot. For each value, multiply it by the first, fifth, ninth, multiply it by the, oh, good, no, wait. I'm overthinking this. Am I overthinking this? Boom, 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 boom. Okay, that did one loop. So we can do a for loop from 0 to 0 to 4, and then after it finishes, so for 0, it runs the for each, and then we do get element. Get elements 0 through 4 plus the times, no. Yeah, plus 4 times this. Yeah, okay. Let's make the one hot. Okay. So we can take a for loop. From 0 to 4. We can do a for each here. So for each in here, we will go to I need to make a dictionary. Okay, for each item, we will do a mult. Okay, I need to move all this. Oh. Oh, perfect. Okay, so for each value in here, going to get element, list get element, which list? This list here. We will get the element at index index of. This is just a lot of me figuring out. Since that's going to be a bunch of zeros, I guess we'll just do an increment variable. Okay. Is there like a counter? Nope. Okay. There's no way. Okay. Current output is 0. This can't be right. This cannot be right. I refuse. Oh, I guess I can load this. Ugh, okay, fine. I'll do it. Load. Who wired that? Don't do that. We're doing 16. So that gives me 8, 7. And then this is such a stupid way to do this. Nope, this is correct. And loaded that. Okay, so we have a loaded that. For each, we can have it increment this, and when it's done, we will, when it's done, yeah, we literally just set this to 0. Okay. And that'll reset it. And then index of is where we get the element. Holy moly, this is already spaghetti. Okay. Boom. Take 1 hot of 16. For each item in this, we will get the, for 0 to 4, we do that. And then I will add a mult, because we need to multiply by 4. Index that by 4. So that plus, so we need an addition. Okay. And I need to move everything because I'm getting lost. Take that index is this. Let's get, holy moly, okay, there we go. So we did that, we get the element, and the reason it's nan is because of that. Okay, yeah, so we do 16 times 4. Okay, so how do I load 64 values into that? I guess, oh, I just did this. So 4, random float, list add. Okay, boop, 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 boop. 0 to 64. Dope. Okay, so this has been loaded. I'm gonna, whoa. Move you down, and yeah, we're gonna just move you there, and you down here. So this is the loading sequence. Okay, now we get elements, so now this shouldn't be null anymore. Yep. So we multiply for each value, we multiply that by this. This is just getting the one hot. And then we just need to list add. You're not the target. You're the target. Boom. Okay. We list add that. Which should yield us a, because this isn't summed, this is just a sequence like this. So it's going to be the same dimension, because it's just 4 times 16. Oh no, wait. So we're getting that. Wait, so you're telling me we end up with something like this? Nope. End up with something like that. Oh, whoa, hi. Did you just comment? Who even are you? Well, thank you for saying hi. This is a stupid project. So we go to there over to the main matrix of output ones. So these are just random. And this goes so this just clarifies everything. So it would realistically just be the same dimension of 16 by 4. Okay, yeah. What? I'm crazy. I don't even need to be saying all this. So 16 by 4. And then I move. What in the world? This is a different type of multiplication, so I don't know how to. I'm overthinking it. I'm overthinking it. For each. Oh, and I lost track of it. Why do I have it wired into here? This doesn't do anything. Okay. For each value, loops into there. When it's done, finishes that, check, check. Gives us the index of what we're adding. This gives us the index of this. We multiply these together. And then for each one of these, we add that. And then when we're done, since this is a for loop, it's closed, so I don't have to do anything here. So, oh, my head hurts. I run this should fill up to 64. Yay. Yay. Okay, 64. That leaves... Oh, I should label this at some point. Anyways, now I got to do... So this is... We're now in the 16... So you have these 16 by 4 of just the one hot. So like this, and then the rest are zeros. Rest are zeros here. And then we have the output, which I should keep color consistent, of 4 here. So these can be whatever variables we want, or whatever floats. Across, across, across. And that means that when we do the matrix mult there, that should lead... What? At least, okay, it's not that bad. This is so small compared to the other ones, I can do this. So, we're going to be doing dot products. This is going to sum all of them, so I do... This is bad. Dot product, so we'll get index 0, index 16, index 32, and... Well, no, 0, 16, 32. Am I 0? This goes to 16. Oh, 48. And then 64. Yeah. Okay. So we'll have to jump by 16 and do the exact same thing over here. 32, 48, 64. 16, 32, 48. Yep. And then for each value that we're working with here, so let's work with this one, for example. That should lead us... So we can do 4, and I'll do 0 to 4, and then, so we do a 0 through 4, and then a 0 through 16. That's gross. So we do the first, so we start on this one, and then multiply once, twice, and this will go index of this plus 16 times this one. And that should give us accurate indexes. And then once those are added, that should be it. Oh, and then I just have to softmax, and I can just take that from softmax. Oh no. No, this is the clean one. Is it? Softmax should be here. Wait, it should be here. What is this? It's this. This is it. Oh. Found it. Found it. Nope, not that button. Yeah, that's E. Yep, this is, okay, yeah, this is it. Okay. Nope. How do I do this? Is the level cap over 50 now? Whatever. Okay. So let's set that up. Zero to 4 and 0 through 16. We can use a for each. For each item, oh, we'll need 2 of those. And no, can I even do for eaches? I think I'll have to do get element. Oh wait, what am I doing? This doesn't even hook up to that. You fool. Okay. Did he respond to my message? No, he didn't. 0 to 4, 0 to 16. And then index of list get element. And we can do, oh, my one viewer just left. Why were you even watching this? Okay. The clickbait worked. Anyways, list get element of multiply and an add. Okay, so I will multiply the index multiply that by 16. And that gets added to this index. And then this is the index that we're going to be using. And we'll pull it from, oh, I can use both of these. list get element. List 1 is this. List 2 is this. Okay, so that's for each item. And we do 0 through 4. 1, 2, 3. Okay. So this should give me those elements. Oh, I'll need a quick list. Okay, quick list of those. Oh wait, oh no, oh no. Oh no. It'll have to be for each 4. For each one. Wait. Oh, wonderful. These are just switched. Okay. So that'll be for each of the 16. So we go slot 1. And then we go, the next index is plus 16 times 4. So plus 16. Yep. Yep. What? Oh. What? Oh. There we go. Okay, those are both filled. Now, no errors. There we go, no errors. So by the end of 4, so for each loop, we'll do a list add into here. And I need a multiply. Huh, it knew. Okay. Let's add that into here for all 4 of those. And then at the end of that, we will list sum. Hell yeah. There to there. Then we do another list add into our another list add into here. And then when it's done, we do list add here. Clone this. Oh, is there a list clear? Yes. Okay. So once it's done, we clear, and it's done. That should sum up the first four, and then, so for each loop, we add. When it's done, it goes there, boom, boom, boom. And then that should end up with a list float of 16. Wait, yeah, it would be a list float of 16. Do we run this? Wait, am I missing anything here? Ooh, I was so good at logic. Okay, so this should theoretically I have no idea how to test this. Wait, so we end up with a float of 16, like I know. Do we just softmax? Let's just softmax and just hope it works. Wait, what? Why does this output a list of floats? This should be a probability. This is loss. This should end up Weeball. Weeball. List sum. There's no way in hell this works. What? How do I see what's in here? List. List onion. List. Do I really just have to do for each? How's this set up? Float to text. Oh, to string. Okay. Oh. That can't be right. That cannot be right. That would explain why this breaks. Whatever. Let's. Don't be lazy. Just make it yourself. Okay. Actually, what is the list sum here? What? No. No. Okay, I just need a bunch of strings right now. This is not good. Wait, input didn't process correctly? Wait, what? No way, I just screwed it up in the beginning. Are you kidding me? Um, oh, that's what, oh, okay. Boop, run that. Set this to 1. Run that. Add that. Set this back down to 0. And then do the rest here. There we go. And now we should clear these. No, these don't even need to be cleared. What am I doing? You're random values. You're random values. You're also random values. You're all random values. Right? No. No, 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 no. You're the only one that needs to be cleared. Boom. Okay. Count of 0. Count of 64. Count of 64, yep. And it should read... Yes. Oh, this is perfect. Okay. There we go. Now that we're referencing that, this is cleared. Cleared that. Everything's clear. So now when I run this, we should end up with 16. Oh, that's good. 104%. I didn't even know it's possible. This isn't right. This isn't right. Wait. No. We go one hot into random dictionary, which is a bunch of floats. And when we, well, of course this would just end up with a single digit. So what's the softmax for? Oh, I don't understand it. So in this case, I did, well, these are completely different. Google. Contents. Wait. So we do one hot X. So the one hot goes against the dictionary. Should. Oh, I know what I did wrong. I figured it out. Okay, so this, I don't know how to do this. Can I do that? Can I like, there. This is what it should look like. So, okay. Um, should I post this? Um, uh, share. Okay. Anyways, back to this. So we have, I need to rotate it, which is annoying because I don't. And then, wait, so when we multiply, okay, wait, let me make sure I'm understanding this correctly. Wait, can I just remove all the zeros? That's so scuffed. List, um, list except. Well, that doesn't guarantee, because not everything. I guess I could just add super small zeros to everything. No, but that doesn't work. Ah, dang it. How am I going to rotate this thing? Well, so I'm supposed to end up with just a vector because it goes 0, 1. Wait, so we do row by column. Oh, I've totally misunderstood. Oh, I hate how I forget how multiplication works. Okay, so we got, what am I circuiting? I'm making a, so there's this thing called word to vector. It's a word to vec. It's a neural, I don't even know how to describe it. It's a vector embedding of words. So it's like using numbers to represent words, but I'm screwing it up. I'm screwing up what it's supposed to look like. And like this is all like much more difficult. All this garbage is so much more difficult than what I'm doing right now, but I'm messing it up. So it's like because I'm getting the matrix multiplication wrong because I didn't do well in linear algebra. But anyways, so we end up, so this could be like the vector for like, I have a pen, vector for A, B, no, that's not letters, A, the, apple, and like cat or something. So we have the values for A here, and the values for the, and blah, blah, blah for all of these. And then we take our one hot, which is like 0, 0, 1, 0. So like, let's say I'm trying to get the value for apple. Like we're going to run apple through the embedding system. And when I do the matrix mult, so so the one hot, okay, see, oh, that's where I messed up. This is supposed to be this way. There we go. that would fix a lot. So row column, so that means we multiply 0 by this. Okay, well, if I wanted to get the word apple, I would have to do it like this. So multiply that, so that goes to 0, this goes to 0, this goes to 1, so whatever the value is here, and then multiply here, so this goes to 0, then you do the next column, so 0, 0, number here. So then that leaves us with just a single row by column, bam, bam, bam. Just a single list of numbers that was in a section there. So yeah, no, that's what I'm messing up. Oh, that guy left. I'll admit it was confusing for me too, and that's okay. Anyways, so I need to rotate that. I don't even get what I'm doing wrong. So we have the one hot here. It's a 16 float, yeah. And then I should be multiplying that. I hate matrix multiplication in Rec Room. So that by, no, wait, please tell me it's not. Is the dictionary actually going to, okay, so the input embeddings, this is so bad. So I'm using a vocabulary of 16 words, and the dimension, or the embedding like space, is just 4, because I'm trying to see if I can get noun, verb, adjective, and adverb. Those are the 4 like variables that I'm trying to get in. So for Rec Room, because I have a single string of floats, a list of floats, because there's no lists of lists in Rec Room, which is really inconvenient for this. We're just going to have a 64 length matrix. Nope. List. And I'm just going to have to go, so index of 0, and then add 16, and then add 16, and be multiplying these values by the one hot, which would also be 0 by 16. So 0, 0, 0, blah, 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 1, blah, 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 0. This is 16 long. So row by column, and that should end up with a single 4 length vector embedding of the word we're trying to get. So I'll have to be doing okay, I guess in terms of Rec Room code, it would be for each value in, I guess we can call it one hot. For each value in one hot, we'll take that value and we'll mult that, and we'll have to do above that a 4, and then we'll go from 0 to 4 there, and then run that into there, multiply 16 but 4, so multiply that by, because one hot is 16 values, so it'll be index of this, so this can be like I times 4, and then add that to the index of input vectors. This is stupid. Everyone's gone. Life is pain. Oh, I just disconnected something. Okay. Anyways, I will do a 4. So we get a 4, and that'll be 0 to 4. For each item in this, we will go for this, I have it technically. I just I guess at every index of what is that? Every index of I? Okay, is there a cheap, can I like cheese this somehow? Can I like list remove all instances of 0? But that could result in fine. List get element. Okay. So we'll get list element and index of. So we'll get the first index of 1 from the list 1 hot. First index of 1, index 8. So for 0 to, yeah, I guess we just do it for 0 to 4. For 0 to 4, we do list get element I need a mult. By 4. No. There. And which list? This. Nope. This. Oh, so I guess we would do it from 1 to 4? List get element, and then we just do a list add. We can bring this to list float list. There you go. Nope, don't connect to that. Connect to this, and then okay, this is really tiring. And I don't even know what I'm going to call this. I guess it'd just be, so 1 hot by W by input. W input. And that should result in well, no, so it should be at 0. 0 to 4. 0 to 4. Do I just add 1? No, wait, that's stupid. index of from 1. Well, if I do 0, then that'll loop it 4 times, and I just need index of add 1, then that'll be, what am I on? Index of 2? Am I on something? What is happening? I can't for the life of me. Oh, I'm going crazy. This is going to be really annoying to debug when I look back at this. So we have, what am I even working on? This is the first part. Okay. Yeah. No. We'll just, so we need the first index of, could it just start at 1? We just go index, so we need index of 8. Yeah, so we would just do 1. Oh, and then we just have the final done as well. Perfect. That should properly add okay, almost. Why? So we do 1, 2 times 8 is 16. Index of 8 should have what? Wait, so we have 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, that's why? Okay. So index of 8. So get index of 8. Then go to the 16th. How do I guarantee that? Is it plus 16? I guess it would just be a plus 16, yeah. Oh. Wait, plus 8. Plus 8 times. You know what? Screw it. If it breaks because one of these is a perfect 0, that's not my fault. That is not my fault. List add. Oh no. List. Get list of all elements that appear in the first list. How do I remove just 0? Oh. this. This makes things so much easier. Target, remove zeros. Fine, I'll list clone it. List copy. And we will copy from here, copy it to here. And when that is done, boom, we take that. And then, boom, we remove all zeros. What? No, that's still wrong. We ball. 1, 2, 3, 4. Okay, it worked. It worked. Kind of. 1, 2, 3. Why does it have 23 values? You're clear. Yeah, you're cleared. You are the one hot. You're fine. You don't need to be cleared. Do you need to be cleared? No, you're 64. You should be cleared. 1, 2, 3, 4, 5, 6, 7, 8. Wait, 8 values is not right. Okay, let's try it again. Yes, yes. What? How? Oh. Oops. There we go. Clear it again, run it back. Boom. There we go. So this, oh my gosh, all that work for that? Are you kidding me? And then I take, so now we have a list of 4, and that's gonna be multiplied against so now this, so if let's just say we had 0, 0, or so let's say we end up with like 0 0.2, 0 0.7, 0 0.4, 0 0.1. That's what we yielded. That's this, just transposed. Now we run this. Row has to match column. So this should wait, so row by column. What? No. No, this is wrong. Okay. So we have row of like this. So 0 0.4, 0 0.7, 0 0.3, 0 0.1. Okay. This is multiplied into here. And that should yield how similar each one of these are. So we're going to get, so this is 0 to 16. So for each value, 1, 2, 3, 4. So now, for each value of 1 through 4, and this goes 16 long, who's even watching this? There. Wait, what? Oh, this is how this works? Oh, whoa, what the heck? Whoa. Sorry, I'm just looking at, what? Not this video. No, I've already seen that. I work, and this is, what about live streams? How can I see what my live streams are doing? Bam, content, live. Oh, analytics. Huh. Who are these people? Oh my gosh, they're all subscribed to me. Wait, that's so nice. Oh, and I said, who are you? Oh. Oh, I feel bad. Oh, I feel a little bad. 46 people can see this? Oh, sorry, I'm so distracted. Back to work. Back to the sweatshop. Oh my gosh, you're my second top fan. Oh, I'm so sorry. Anyways, so for all 4 of the values, we will go tick, 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 1, 1, add 16, 2, add 16, 3, add 16, and then go to add that together. So if I just swap this, this goes to this list add, and this goes to this, and now this goes to this. What does this yield? No way, wait, this looks a lot better. Wait, this doesn't have a list clear. Okay. Boop, boop. To here, clear that, run it again. It should be 16 long. So we add, oh wait, no, this goes to here. This goes to here. What? How do I see the maker pen? Index 64 is out of range. Because it's index of... Oh, shit. They're different. This is grabbing from there. Why? So we grab 0 to 4, 0 to 4 going to here. This, what? You're going to here. Now we run it. What is your issue? What is your problem? I'm not using an int. 0 to 4, 0 to 16, exclusive. Float lists are all cool. What? Where's the issue? So I clear you. And this is referring to a list of 4. This goes from 0 to 4. Check. 0 to 4 goes to 64. Wait, is something not resetting here? Okay, it's at the get element. It's at this. And that's because it's looking at the output float, yeah. And this has a value. I don't get the issue. When it's done, it clears everything. Running this goes to here. We get the element, index of 0, goes to float here. Oh, is it because this has to go to 4? Nope. Why is it only 4? It should be 8. Wait, what? Should be 16 long because we're going by 4, summing that. So from 0 to 4, index of this one, yeah? We get the value multiplying with element 0 from multiplying with element 0. Wait. This is float. Yep, check. And we go for element 0. And that starts at 0. We go... Wait, why am I going by 16? It should be... Go by 4. 1, 2, 3, 4. 1, 2, 3, 4. For each value in here, we take index of 0, 16, 32, 48. Oh, and then from 0 to 16. Nope. So that was set up correctly in the first place. I'm stupid. And this goes to list add. Okay, so this goes for 0 to 16 for each value in there. We add 16. 0 to 16. Then we add 1. Wait, so from 0 to 4. Boom. We take that, and then we index 4 of that one, and then we take index of 16 of this times 16. Yep. And then we add index of that, and then we do 2, boom, 3, boom, 4, boom, yeah. And then we go to the next one, and that will do adding 1 to our index. So it would be, this goes into here, but instead of adding it from there, we're adding it from here. One, two, three. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Thank you. Thank you. This is going good now. Run this list through here. We got the list some over there. Should be 1. Yes! Yes! Oh. So this should show the probability of, no, this should show the probability. Poop. Wire that to that. And this should add up to just barely 1. Yes! Okay. Of training of Word2Vec, just need to add loss and then add loss and update weight matrices. But how long have I even been working on this? An hour and a half? 2 hours? Nope, 2 hours is too long. Okay, that's cool. And that's the log of building the Word2Vec forward pass.